Hello friends, welcome to my channel and cooking center. So today I'm going to explain your 11th standard physics concept, that is physical law. So as you know, till your 10th you have studied science as one book. All the branches you studied as one. Now you are studying as different branches, 1 to 11th standard. So let's come to your physics concept, that is the physical world. So what is physics? As you see in your day-to-day life, there are many things happening, like regular repetition of day and night, cycle of seasons, eclipse, volcanoes, rainbow, many things that happen in your daily life. So it is also related to science and technology, and various things that are also related to physics also. So let's come to the word science. The word science, what it says? It says about know. To know something, it says, and in different languages, science means different things in different languages. So let's know what is scientific method. So scientific method, so it is science is a systematic attempt to understand the natural phenomena, or to understand the things, to understanding the things and take some details about it and learn some depth knowledge about it. So to learn that, it is we call as science. And science is of exploring, experimenting, predicting what may happen if you do like that, what may happen, that predicting and exploring that new things by doing experiments. These are the science, and there are some scientific methods that are involved in these steps. So these steps are some scientific methods. So let's know the method is systematic observation. So we should observe what happens if we do like this, what happens, and controlled experiments. So if you do any experiment also in science or any in physics or anything, if you do any experiment in science, it should be in our hands control. And qualitative and quantitative reasoning. So it should be qualitative and quantitative. And in which quantity, if you are doing a chemical reaction, if you put this much quantity of chemical, then you get this thing. The qualitative and quantitative reason should be there. What, how you done, what you are getting results. The reason should be there, and you should say modeling. If you are doing an experiment, there should be modeling. There should be drawn diagrams for understanding easily for the next generation students, or for understanding for the scientists or students. For that, there should be a modeling and prediction and verification. We should predict this happens, and we should do it and verify it. And also speculation and conjecture also have a place in science, and ultimately the science theory is acceptable. So the science is acceptable ultimately. Finally, whatever we do in science, it is acceptable if we have done all these things. And there is a physical debate about the nature and method of science. There will be debate in some places, so you have to discuss in your classes, do debates on that. So there are many scientists among in the past, and some of them are John Kepler examined the existence data of planetary motion. So motion of planetary existence, John Kepler said that about that, and you will learn about that also in your next upcoming chapter. Three things you explain this last period, last habit and last area. About that, you will understand in your next upcoming physics chapter. So next is Tycho Brahe, and also the Tycho Brahe, the planetary circular orbit theory, and the helicocentric theory also is explained. And Nicholas Copernicus had replaced the elliptical orbits that you had Copernicus, you also have learned. So these are some 20th of 20th century, and Newton mechanics, and many other successful scientists like More scientists have came and they also explained the new theory in physics and other branches of science. So let's learn about physics scientists. So physics is a basic discipline in the category of natural science. So it is a basic discipline under the category of natural science in the natural science, and which includes the other disciplines like the physics and as in science, math, chemistry, biology, and physics. So physics is a branch, and the physics word comes from a Greek word meaning nature. Physics means a Greek word says about it is telling us as nature, and many other words are telling us about it. And the scope of physics is described briefly in the upcoming sessions. What is the use of physics and how it will help you to develop your life, and it will help in your life, they also say. So here we remark on two principles the two principles on which the physics work is unification and reduction and unification, and these two principles that physics work. And in physics we all attempt to explain the terms of few concepts and laws, how it works, the laws we explain in the physics. And many more laws are the law of gravitation, law of electromagnetism, law of gravitation, Newton explained, and many other laws are there that I have explained. And a related effort that we derive a property of a bigger, more complex system from the properties to interaction of its constituents in simpler parts. So explain this bigger things into simpler parts is called as physics, and also the approach is called as reductionism. Means this explaining is called as reductionism. Means reducing the bigger part we are explaining simple. That's all. And there are many things in the physics that we explain in simple, like power system, kinetic theory, and statistic theory. Many more theories are there in the physics. So this is what basic things we learned about physics. So next we learn about the scope and excitement of physics. What is scope and what are the excitements we get when we learn the physics, how it works, how it tells us about it. Let's know about that. So basically there are two dominant interests. There are macroscopic and microscopic physics are there, and the macroscopic domain includes the phenomena in laboratory, terrestrial phenomena, laboratory examinations, and many more things. And microscopic is the atoms, molecule, atomic energy, atoms, energy, and that phenomenon is called as microscopic. And the classical physics is also there. Classical physics deals mainly with the macroscopic phenomena. The first one, macroscopic, with that the classical physics deals, and it includes some topics under classical phenomena. Some things we learn under classical phenomena are called as mechanisms, electrodynamics, and optics, thermodynamics, and these all things we learn under the classical physics. And thermodynamics and all chapter we have in here. So we learn about that. So let's see the more things we learn in the physics, and this was the basic things about the physics, and still more basic things are there. So let's keep on learning some basic things, then we will enter to the physical world. That's some basic concepts, and after that we will start our next chapter after finishing of this chapter. So let's go another basics. So there are electronic gases, ejecting gases, many more things we learn in physics, how it works, and the basic law is given as Coulomb, and overstate chemical process, etc. The problems that we learn in thermodynamics. And as you know, the second is microscopic domain of physics that which deals about the construction and structure of matter, atom, and the theory of quantum theory, and framework for exploring microscopic phenomena. Overall, we learn the beautiful things of constructive physics. these will give you more interesting things and it will teach you more interesting things about physics. And here the first thing you are learning is the theory of the experiment and the theory of scattering of experiment of Rutherford. So this is Rutherford's experiment we are learning. We learn in our next chapter also. Here they have given only the photon. So Ampere and Federace are the other two scientists, and encapsulated by the Maxwell. They are the some scientists, and many scientists who thermodynamics and mechanisms who work on thermodynamics and mechanism, and they give out microscopy, physics experiments, microscopy, and this was the microscopic. And you have known the scope of physics is truly vast. There are vast scope of physics. It covers the dynamic range of magnitude with an altitude. Many things you can learn the physics. It is like a general knowledge, and many phenomena, how to measure the weight, mass, speed, and some of the units they have given here of mass, speed, of light. Like many things you learn in the physics that will be more and more interesting. If you understand it, you definitely can score the good marks in physics. There is no doubting about that. So the physics is exciting in many ways. So now let's know about, now we learned the microscopic and microscopic physics. Now we learned why it is exciting, how it is exciting for you, how you should learn so that it will make it more exciting for you and you will understand it. So let's know about that. Some people, the excitement comes when they, some people it comes excitement when they work on that, from the fact that basics on concepts, on physics quantities, on many things, and it is demand application and experiment of physics laws and learning of physics laws, learning and finding new physics laws. It will make more excitement. There are many laws. First it was realized that for scientific progress there was only quantitative thinking through no doubt important. So there is no doubt important is not enough. So quantitative measurement was the central to the growth of, so quantitative measurement it was central to the growth of the science and physics they had said. But now they have not said like that. Now they are saying that there are many ways to find new laws, and you can find it, and there are many laws they have found during that period of gravitation, and many laws they have given. And here they have given what to physics, technology and society, how physics helps for technology and society. So physics, technology, society, many examples are there. The discipline of thermodynamics. So the discipline of thermodynamics, how engine works, how steam engine works, how heat heats, many things they have learnt, and that steam engine. And also there are many things they have learnt. And also they are saying that they have in 1993 at last in 1993 Rutherford explained about atomic matter, and also many scientists have explained many theorems in the many things in physics, explained the laws of physics, laws of motion and many things. And in most significant areas in which the physics will be contributed to in the development of energy resources, the alternative energy resources is also its contribution, and many sources of energy are made or generation of new making of source of energy like solar energy, geothermal energy, nuclear energy, many energy in its contribution. Physics also gives its contribution towards the making of energy. And in technology also it is giving, because physics also helps to society, because making of smooth train in that physics is involved, how the train works, and making of new energy it helps for the current fault of society, and many things physics will help. So also table 1.1, so this table 1.1 listed about the greatest physicists and their contribution. It also tells And another table 1.2 is here. It gives us list about the principle, important principles that we have to learn. And there you will get many more books and you will learn many more things of physics in the upcoming chapters and in your upcoming classes. You will learn. So let's come to 1.1 chapter. This tells about the physics from different countries of the world. The physicians like Galilei who tell about law of inertia and he's from Italy, and Archimedes who tells about the principle of fire, and Christopher Huygens, Christian Huygens who tells about the wave theory of strength, and Isaac Newton universal law of motion, universal law of gravitation. Isaac Newton is a specialist physician in his son. And Michael Faraday who told about the law of electromagnetic, and James Clerk Maxwell who told about law of electromagnetic theory and law of electromagnetic wave, and many more scientists, and mainly Albert Einstein who told us about the theory of relative and photoelectric effect. So these are theories you will be learning in your upcoming classes, and when you go to higher classes you will learn, and many more theories are given. So these they will not ask you in your exam. So let's know about fundamental force in energy. Let's go in nature. Fundamental forces that we see in our nature is there are many forces, like if a car is moving or if you push someone, there are no force. How it works? So earlier thinkers like Aristotle had some wrong ideas about that, and the correction of mutation and the correction of theory was done by Isaac Newton, who gave us information about law of motion. So he said us about the gravitation, who attracts us, the two bodies. The thing that attracts the two bodies is called is gravitation. The attraction between the two bodies is called as gravitation. So the friction is the thing that stops the attraction between the two bodies. And also he says about the thought, he says about the things, and he try to explain many more things. So till here I will stop. I will explain that some more things about chapter in my next video, and fundamental forces in nature in my next video. So okay friends, so I will explain the second part in my next video. So till here you understand about the basic things of physics, why you should learn physics and what is the scope of physics, and why it is excitement. So I will explain the other topics of this first chapter physical world in my next video, and other topics in my upcoming video. So till then, like the video, comment on my video, and subscribe my channel and including generated for more videos of first QC, and also share my video with your friends so that they may understand. So okay friends, thank you, take care. I will see you in my next video. Till then, take care. Have a nice day friends.